Welcome back, everybody. So we're still continuing on with the confidence intervals section here, but we're now going to just have a quick look at this margin of error. And the margin of error is the distance, or the difference between the sample proportion and the endpoints of the confidence interval. So essentially, if you look back, if we look at the margin for error formula first, the margin of error formula is z times the square root of p hat times 1 minus p hat over n. That formula is actually just, when we go back to the confidence interval formulas we had before, it's just the z times the square root part, right? So it's the same as the confidence interval formula, but without the p hat minus and the p hat plus. In other words, if you look back at this graph, really the margin of error is just this difference between the middle of the interval and the maximum of the interval, right? Like from there to there is the margin of error, right? And that should be the same distance as from p hat to the bottom of the interval, right? So the margin of error is just the distance from the middle of the interval to the top, or the middle of the interval to the bottom, which will be equal to just this part of the formula here. All right, and that's all that's shown on this page. So that means, the way we work out z is the same as in those previous examples. So if it's a 95% confidence interval, then z will equal 1.96, and this will become the margin of error rule. Okay, and again, the 95% confidence interval is the most common one, but it's not the only one you'll ever do. So really read the question carefully. Don't assume it's always going to be a 95% confidence interval, because it's really common error to use 1.96 and then realize later, oh, hang on, it's not 95%, it's a different percentage. So just watch out for that one. Okay, on that note, let's get into one where it is 95%. Anyway, example 3, statisticians believe a sample proportion to be equal to 0.3. They wish to achieve a margin of error of 2% in an approximate 95% confidence interval for the population proportion. Okay, so we've got 95% confidence interval, right, which tells us that z equals 1.96. My dog's confirming that. Yep, z equals 1.96. That's what he just said. What is the minimum sample size required to get this margin of error? That just had to quiet the dog down. So we've got this question here where we're saying we want to achieve a margin of error, of 2% in an approximate 95% confidence interval, which means z is 1.96. And we have to find the minimum sample size required. So basically, this question here, minimum sample size, was saying that n is the value we don't know. But we know that we want the margin of error to be 2%, so that's our m. So let's just practice, and it's a good way to do the question anyway. Let's just start with this formula, this margin of error formula, and fill in the numbers that we know. So we know that we've got, m equals, so 1.96 times the square root of, so p hat, it says that we believe the sample proportion to be equal to 0.3, so that's our p hat. So it's 0.3 times 1 minus 0.3, which is 0.7. So you kind of notice with this formula that those two numbers together are always going to equal 1. It's a good little check. Divided by, now n is the value that we don't know in this question, right? But they want to achieve a margin of error of 2%. So we actually want this value, this m, this whole expression, to equal 2% or 0.02. Right? Now, what we should hopefully notice here is that this formula, this is now just an equation with one unknown number in it. As we know, once we have an equation with one unknown in it, we can always solve it, right? So we're just going to solve this equation for n to find the minimum sample size required to achieve this margin of error. So let's work that out on the case. There you go. Solve 1.96 times the square root of 0.3 times 0.7. I'm going to use x instead of n just so it's a little bit easier. We want that to equal 0.02. And we get x, or n, equals 2016.84. So n equals 2016.84. Now, as a sample size, a sample size is discrete, right? So we can't have that decimal value. We need to have a whole number of samples. And the idea is that the bigger the value of n, the smaller this margin of error is, right? Because n is on the bottom of a fraction. So increasing the value of n will make the margin of error smaller. So the minimum sample size, to get the margin of error down to 2%, or make sure it's down to 2% or lower, we would actually have to go up to the next whole number. So n will equal 2017 here. That's the sample size required to get that margin of error down to 2% or lower. All right. This exam question's probably a little bit tacked on here, but this might be a good one now to actually pause it, have a read, and have a go for yourself, and then sort of play the video and see how you went. So this one is a good past, it's a multiple choice question from a past exam. An opinion pollster reported that for a random sample of 574 voters in a town, so we've got 574 is our value of n, 76% indicated a preference for retaining the current council. So that looks like our p hat. That's a sample proportion. That's 76% of the sample want to retain the current council. An approximate 90% confidence interval for the proportion of the total voting population with a preference for retaining the current council can be found by evaluating. So in other words, we want to find the confidence interval for the population proportion based on this sample, right? So that's just using the confidence interval formula. So key thing to watch out for here is that this is a 90% confidence interval. So we might say for 90%, right? Remember that we need to find that Z value in the formula, okay? And we have to kind of think of it as like, well, if I'm thinking about Z as the standard normal distribution, the mean is 0, the standard deviation is 1. If I want the middle 90%, so we want that to be 90%, what are these values here and here going to be that give me 90% in the middle? And so remember that the way we did that was to use the inverse normal distribution. So distribution, inverse norm CDF, change the tail setting to center because we want the 90% that's in the middle, probably 0.9. It's the standard, we're talking Z is the standard normal distribution, so you keep the 1 and 0 the same. Okay, and we get, negative 1, remember it only gives you the left end of the interval, so it gives you down here negative 1.64, and that would be positive 1.64. Right, so in other words, Z is approximately equal to 1.64, so Z equals 1.64. And so when we look at our options here, right, so we're going to essentially be trying to find which one of these looks like the correct, or which one looks like the confidence interval formula set up correctly. So remember that the formula is, for our lower interval anyway, is p hat minus Z times the square root of p hat times 1 minus p hat over n. And then the upper interval is exactly the same thing but with a plus here, right? So in this question, we said, well, p hat is 0.76, right? So A looks like it's got the 0.76, A, B, C, D. D's got something weird going on, so I think we can rule out D straight away. That doesn't have 0.76 at the beginning here and here, so I think that one's just wrong. We also need to have, looking at our formula, the correct Z value in front of the square root, which is approximately 1.64. So let's have a look and see which options look like they have that. Well, if you accept that the question's actually or the answer's actually rounded slightly wrong, this one's got a Z value of 1. That's not it. This one's got 1.65. That one's 2.58. That's a no. That one's a Z value of 2, so that's a no as well. So B looks like the correct option just based on the fact that it's using the correct Z value there. But of course, we should double check to make sure that the other bits look right as well. Underneath the square root sign, we've got P, so we should have P hat, which is 0.76, yep, times 1 minus P hat, and 1 minus 0.76 would be 0.24, yep, that looks right. Divided by N, where N is the sample size of 574, yep, that looks right. And then the upper end of the confidence interval should be exactly the same sum, but with a plus instead of a minus, and yep, that ticks all the boxes, so B is the correct option. So a good one to see, I guess, how the knowledge of the formula might come in handy here, not just being able to get the final answer, because this question was really about, I suppose, checking which option substituted the numbers into the formula correctly.